Lesson 8.4 is our first delve in Algebra 2 in rational expressions. However, you worked with this back in Algebra 1 some. And I know that because Mrs. Rogers was just working with her kids with it like a week or two ago. So, with that in mind, we've seen some rational expressions. Rational expression, remember, if something is rational, it's something that can be written as a fraction. So a rational expression is of the form p of x over q of x, given that p of x and q of x are polynomials. So as you look through this page, polynomials, they are basic x terms added and subtracted together. Okay? The simplest form of a rational expression is when both the numerator and denominator have been factored and reduced. Remember how we were finding holes where we had to factor so then we could reduce any factors that might be in common? It's the same type thing. We're going to factor and then we're going to cancel. So there's an example here. This example, x squared minus x minus 6 over x squared plus x minus 2. Well, remember product and sum? You're going to see a lot of product and sum today. This factors into x minus 3 times x plus 2 over x plus 2 times x minus 1. Well, the idea is what can cancel here? Yeah, x plus 2 can cancel with x plus 2. You're left with x minus 3 over x minus 1. So that x minus 3 over x minus 1, that is your answer. And then we also have to talk about, I call them excluded values. Officially right now they're talking about, we have to talk about restrictions on the variable. And the idea of what do we know about a fraction and the denominator? The denominator can never equal 0. You've heard me say that time and time again, right? Well, if you look at x minus 1, you set that equal to 0, that's going to equal 0 when x is 1. X plus 2, which was part of the original problem, that would equal 0 when x is negative 2. So these are the restrictions on the variables. Or again, some books call them excluded values. So x in this problem, to make this be a valid fraction, x would not be able to equal either of those values.
What do you do with the other x then? Because it's x squared minus x minus 6. What happens to the other x? Yeah.
We're using in terms of the negative x. That comes from your outside and inside. That comes from the fact that the 2x on the outside and the negative 3x on the inside, 2x plus negative 3x is negative 1x.
Because you have the x squared and you usually would just...
Right, because we usually just...
factor.
Yeah, we're going to set up, and that's what we're going to be doing. Okay?
I was confused because there's 2 x's, but there's 3 x's.
We'll look at it when we have to start unfoiling here. Okay? I think I mentioned this the other day in class. I know I mentioned it in one of my classes recently. Terms with plus or minus signs. Okay? You sometimes hear this in math, that they're married. You can't cancel them until they've been factored. When we are trying to find holes, I know I mentioned that in one of my algebra classes. I don't guarantee I mentioned both of them, but in other words, the common mistake, let's get it out of the system now, is to say, oh, x squared cancels with x squared. X cancels with x. I have 6 over 2, that's 3, I'm done. No, we have to factor. These pieces, this x squared minus x minus 6, they're married together because they're added and subtracted. We can only cancel terms or factors that are multiplied by other factors. Okay? So, let's look at example 1. We're starting off today with just simplifying rational expressions. But then we are going to be working on multiplying rational expressions and dividing rational expressions. So, what are each of the following simplest form state any restrictions on the variable? X squared plus 7x plus 10 over x squared minus 3x minus 10. Do I get to just cancel my x squareds and my 10s? We want to, because it looks so much easier, right? But we can't do that. We have to think in terms of how do these factor. So, what do you know about x squared plus 7x plus 10. Okay, this is our typical trinomial that factors into two parentheses, right? X squared breaks into x times x. So as long as it starts with 1x squared, it's going to be x times x. Then what do these numbers have to do? They're going to have to multiply or give me a product of 10. And then those same numbers are going to have to add or give me a sum of 7. Well, options that multiply to be 10. 1 and 10, 5 and 2. Which one adds to be 7? 5 and 2, right? So I'm going to say 5 and 2. If it multiplies to be a positive and adds to be a positive, both signs are going to be positive, yes?
Yes.
This factoring sounds familiar. Some of you are bored with me, I know. But some of you really need this refactoring review, so that's why you're getting it right now. Okay, denominator. X squared minus 3x minus 10. Similar setup? Yeah, this is of that x squared plus bx plus c. So two parentheses. X squared breaks into x and x. This time, my numbers have to multiply to be, not just 10 though. Okay, they have to give me a product of negative 10. And they have to add or give me a sum of negative 3. Well, we already talked. Options of multiplying to be 10. 1 and 10 or 2 and 5. How could I get 1 and 10 or 2 and 5 to be 3 when we add them? We're going to have to use the 2, 5 with a positive negative. Not necessarily in that order. I haven't thought about it. Excuse me. So my numbers are the 5 and the 2. If it multiplies to be negative, give me a positive and a negative. If it adds to be a negative 3, larger number is negative, smaller number is positive. And you can FOIL this out to check yourself, right? If you're thinking, oh man, I don't know, FOIL it out. There's x squared, there's plus 2x, there's minus 5x. Oh, 2 minus 5 is negative 3. And then there's your minus 10. Does anything cancel? Okay. We have the factor, x plus 2 cancels with x plus 2.
So you don't do opposite signs.
No, they have to be identical factors. So x plus 2 cancels with x plus 2. If I just said they have to be identical factors, does anything else cancel? No, because it'd have to be an entire x plus 5 cancel with another x plus 5. But we don't have that. So the answer for the simplifying part of this problem is just x plus 5 over x minus 5. Now, we're not quite done, though. Because they had another request up here, didn't they? Simplest form. Check that off. Done. But what else?
Restrictions.
Restrictions. And remember what I said about the restrictions? It's a fraction. The denominator of a fraction can never equal 0. So guess what we're going to do? We're going to take this denominator and we're going to set it equal to 0. Now, you could go back to the original denominator, but that's kind of silly if you ask me. So what denominator am I going to encourage you to use? The factored denominator. Now, that factored denominator, use both pieces. I know we already canceled one of them, but it was still part of the original fraction. And so I'm going to set x minus 5 equal to 0, and I'm going to set x plus 2 equal to 0. So I set both factors for my denominator equal to 0. If it's x minus 5, you add 5. And so that one's going to be, I'm going to say x equals 5, but really what it means is x cannot equal 5. And if it's x plus 2, subtract 2, and we're going to say x cannot equal negative 2. So those are the restrictions on the variables. X cannot equal 5. X cannot equal negative 2. Because those both would make my denominator equal to 0. I really don't remember off the top of my head how the homework looks. But it's probably like a part A, part B, right? Questions on that one? I mean, it's using all skills you've seen before. Okay, it really truly is, so. Okay. B. Looks a little different, doesn't it?
I don't like this one.
Okay. Not surprised. This is the one that, we tend not to like because we are so used to the factoring in the first half, right? In the first problem. This one, here's what's happening, guys. 24x cubed y squared, that is all one term on top because there's nothing added or subtracted. So that's all one term. Negative 6x squared y cubed, that's all one term in the bottom. There's nothing added or subtracted, which means we can just look at like things that cancel. Okay? Anything that's a piece there can, it's all multiplied together. For a visual, I would maybe say break it into like pieces. And what I'm meaning by that is, okay, for my numbers, I'm going to think about, okay, 24 and negative 6. For my x's, there's an x a third over x squared. For my y's, there's y squared and y cubed. So if you think about the like pieces there, think about what can cancel or what can reduce. Maybe I should use the word reduce. What do you know about 24 over negative 6? Can reduce to become, or divide to become negative 4? Now, my answer is going to be a fraction, obviously. When we reduce that, 24 divided by 6 is 4. Positive divided by negative, negative 4. Where was the bigger number at? On top. So where's this negative 4 go? On top. I wrote something wrong, didn't I?
Yeah.
Did I say it wrong too? I bet I did. I don't know. Okay.
I didn't even know that.
The x's. X to the third divided by x to the second is what it was supposed to be. I don't know what I was thinking. How do we simplify x to the third divided by x to the second? If the bases are the same, you can subtract the exponents. So 3 minus 2 is 1. Where does that x to the first go? On top, because there were more x's on top. Do I have to write x to the first?
No.
No, I can just write x. Yes? Okay. What about y's? Y to the second divided by y to the third. Okay. Depending on how you subtract this, if you say 2 minus 3 is negative 1, well, to get rid of the negative, you take it to the bottom. Or another way I like to teach it also is, okay, if I just do bigger minus smaller. 3 minus 2 is 1. Where were there more y's? On the bottom. So where is that extra y to the first? On the bottom. Both are good ways to think about it. And we've simplified everything, right? So negative 4x over 6y. That works because there weren't like terms. There weren't various terms added and subtracted that we had to worry about. They were just like pieces. So we could look at each factor. Now, we can't move on yet though, can we? We're looking for restrictions on the variables. So as you look in your denominator, what kind of factors or variable pieces do we have in the denominator? Well, go back even before just y, but definitely a y, but we have to go back before. We had a negative 6 in the denominator, but negative 6 is just a number, right? It can't ever be 0. We had an x squared in the denominator, and we had a y to the third in the denominator. So when I talk about saying the denominator equal to 0 here, I'm not leaving myself quite enough room. On this one, I would talk about setting x squared equal to 0 and y cubed equal to 0. Well, if you have x squared equal to 0, if x squared equals 0, what do we know? X equals 0, because if it's x squared, you take the square root officially, and so you get x cannot equal 0. If you have y cubed equals 0, take the cube root, and y cannot equal 0. When you have x's and y's multiplied, the key is x and y cannot equal 0. There's nothing added and subtracted, so it's just that they can't equal 0 there. I don't feel like you see as many of these, but you do see them sometimes. And this is just all about reducing fractions. Ready to try C? I'm making you practice these factoring skills today. That's the big deal. X squared plus 2x minus 8 over x squared minus 5x plus 6. Can I just cancel my x squareds? No, because they're added and subtracted to other terms. I can only cancel factors, pieces that are multiplied. So, what do you know about x squared plus 2x minus 8? Can everybody at least tell me that it's set up to go into 2 parentheses? X squared breaks into x and x. What about numbers?
Product of negative 8, sum of 2.
Okay, good. Product of negative 8, sum of 2. So what kind of numbers multiply to be 8?
1 and 8, 2 and 4.
1 and 8, 2 and 4. Which numbers am I going to have to use if we want to get 2 added out of those? Okay, so it's going to be some combination of 2 and 4. If it multiplies to be a negative, signs are positive, negative. You can always test that on your calculator, right? If it adds to be 2, which number is positive, which number is negative? Yeah, negative 2, positive 4, because the bigger number is positive because it adds to be a positive. Denominator, x squared minus 5x plus 6. 2 parentheses, x and x. This time, my numbers need to multiply to be 6, add to be negative 5. So what multiplies to be 6?
2 and 3.
2 and 3, or
3 and 2.
1 and 6. Now, the tricky part on this one is both 1 and 6 and 2 and 3 could add or subtract to be 5. So it really comes down to the signs. If it multiplies to be a positive and adds to be a negative, in order to multiply to be a positive, my signs have to be the same. If it adds to be a negative, both numbers are negative. So if I need two negative numbers that are going to add to be -5, which numbers am I going to have to use? Yeah, the 2 and 3. So -2, -3. So what do you notice?
You cancel your 2s.
X minus 2 factors cancel. I'm left with x plus 4 over x minus 3. Am I done? I'm done simplifying, but I'm not done with this problem, am I? Restrictions on the variable. What can x not equal? No. What is it I'm setting equal to 0? Anything, and let me, as I say this is going to be important, anything that ever was or is in the denominator. I don't care about the numerator, but anything that ever was or is in the denominator. What was in my denominator?
X minus 2, X minus 3.
X minus 2 and x minus 3.
So it'll never be the new, like, simplified one. Well, part of it, but it won't be like.
Right. So once we cancel something, we still have to use that because that was part of the original problem. Because if I go back up here in the original problem and I put 2 in that denominator, I'm going to get 0. So we have to use both. It will never be anything from the numerator. If it was just in the numerator, it would never be anything from the numerator. So we won't use the x plus 4 in this one. So we get that x cannot equal 2 and 3. And yes, you can express them, x cannot equal 2, comma 3. I think Math Excel is probably going to have you use a comma between the numbers. I would say we should skip the next one and go ahead and move on to multiplying, but this one looks a little different, isn't it? So we need to talk about it. Look at that numerator as we start to talk about factoring. 12 minus 4x. Alexis already pointed out it doesn't have the x squared on top, does it? So we're not going parenthesis times parenthesis on top because it's not x squared. However, what do you know about 12 and 4? Okay, they have a GCF of 4. Now, I'm actually going to tweak that a little bit. I'm not just going to use 4, and I'll show you why. So first of all, I'm going to flip-flop this. And if I flip-flop the 12 minus 4x, then that means if I put the 4x first, it is a minus 4x, and then a positive 12. The reason I'm doing that, if I just pick out a 4 and factor out a 4, then I'm going to have a negative x term. But when I do my factoring, do I ever have a negative x first? No, it's always x times x, right? So if I have a GCF and there's a negative involved out front, I would suggest you factor out not just 4, but negative 4. So basically, anytime this is backwards, reverse it and factor out a negative. So if I factor out negative 4, negative 4x divided by negative 4 is x. What's 12 divided by negative 4? Negative 3. So I have negative 4 over x minus 3. Excuse me, negative 4 times x minus 3. I'm not throwing the word over in yet. Because now we have to factor the denominator. Dig deep in those brains. We have factored x squared minus 9 before. This is the squares, right? We know x squared breaks into x times x. 9 is what we call a perfect square, and it multiplies to be a negative, which means opposite sign. So this is doable, right? X squared, so two parentheses, x squared is x times x. 9, square root of 9 is 3 times 3. If it's multiplying to be a negative 9, you need a negative and a positive, or positive and negative. Do we just happen to coincidentally have any common factors?
Yeah.
We do, don't we? What cancels? X minus 3 cancels with x minus 3. What remains for my final answer? Yep, you got it. Negative 4 over x plus 3. I would be shocked if you got a problem today in this lesson and it didn't factor and something didn't cancel. Okay, you're going to be expecting things to cancel. If not, you probably made a silly mistake. If you get to the end, you get it all factored out and nothing cancels, you probably made a silly mistake. Go back and look for it. Are there any restrictions on the variable? Okay. What pieces were ever in my denominator?
X minus 3 equals 0 and x plus 3.
Okay, x plus 3, x minus 3. So those are the pieces I'm going to set equal to 0. X plus 3 equals 0. X minus 3 equals 0. So x cannot equal what? 3 or negative 3. If you wanted to get fancy, you could also express that as
Positive.
plus or minus 3. Math Excel likes plus or minus. They take that. But then you have to find it on the toolbar and remember to use it. So, not necessary, but. Are you getting the feeling for this? Because to be honest, we're getting ready to move to the bottom. Example 2 is multiplying rational expressions. And you know what? We're doing the exact same stuff.
This would be simplified.
Okay? So, it says find each of the following products, state any restrictions on the variables. How do we multiply fractions? Straight across, right? Top times top equals top. Bottom times bottom equals bottom. Now, it would be silly to multiply them as is. Okay, because what do we need to be able to do to reduce these? We need to be able to factor. And so the first thing we're going to do is we're going to start factoring all this. Okay, so all those different types of factorings we did up above,
Except for Morse code.
we're doing them all. So one piece at a time, no Morse code. It's not fancy. One piece at a time. Okay. Oh, because my line dot line. Okay. 2x minus 8. How do I factor 2x minus 8? There's no x squared there, right? So we're not thinking two parentheses. But there is a GCF of 2. So I'm going to put my 2 out front. 2x divided by 2 is x. Minus 8 divided by 2 is 4. 2 times x minus 4. Okay. Denominator. X squared minus 16. Does that factor? We just did something like this, right?
Plus and minus.
This is difference of squares, 2 parentheses. X squared breaks into x and x. 16, the square root of 16 is 4. How do we multiply to be a minus 16?
Plus and minus.
Plus and minus.
Doesn't matter what we use.
Nope. Yeah, when I throw in my signs, plus, minus, minus, plus, same idea. Okay. Numerator, x squared plus 5x plus 4. Guess what we're setting up? It's an x squared plus 5x term plus a constant term. We're going to assume it likely factors. X squared breaks into x and x. Numbers that multiply to 4 and add to 5. 1 and 4? 2 and 2 aren't going to do it, are they? And if it multiplies to be positive and it adds to be positive, plus plus. And x squared plus 8x plus 16. X squared is x and x, multiplies to be 16, adds to be 4. 1 and 16, 2 and 8, 4 and 4. Option is 4 and 4. If it multiplies to be positive and adds to be positive, yeah, to get it to be positive 8, you need positive 4 plus positive 4. Okay. Thoughts on what can cancel?
X minus 4.
Okay. 1x minus 4 on top cancels with 1x minus 4 on bottom. Okay. What else?
X plus 4 is 1 of that.
Okay. There is 1x plus 4 on top. So the 1x plus 4 on top can cancel with 1x plus 4 on bottom. Now, does it matter which x plus 4 on bottom? No. And I'm going to do something on purpose here because I want you to understand that this x plus 4 up here, it's in the numerator, right? It could cancel with this x plus 4, this x plus 4, or this x plus 4. Because it's just like cross-canceling. So to make a point, I'm going to cancel this one. Now, it doesn't matter. If you canceled one of the others, it doesn't matter. I just want you to understand if there was an x plus 4 on top here and there's only one way over here on bottom, as long as you're canceling one top item and one bottom item, and these fractions are being multiplied, it's all good. Anything else can cancel. There's a factor of 2 on top. We didn't have any plain numbers on bottom. There's an x plus 1 on top. Do we have any x plus 1s on bottom? No. X plus 4, x plus 4. Okay, we're ready to write our answer. Our answer. Remember, we're multiplying. Top times top, bottom times bottom. What do we have on top?
2.
We have a 2, and we have an x plus 1. Good news is you usually leave it like this. 2 times x plus 1. I'm not saying 2x plus 4 is equivalent. I don't know that Math Excel would count it. I think they might count right, but I can't guarantee it. On bottom, what do we have left? X plus 4 times x plus 4. You can write it as x plus 4 times x plus 4. Or what's the fancy way?
X plus 4 is 7.
You could write it as x plus 4 to the power of 2. That is what I would encourage your answer to be. Now, they also asked for restrictions on the variable. How do I find my restrictions on the variable? Denominator equal to 0. Anything that was ever in the denominator needs to be equal to 0. So my point is, don't just look at your answer. I would always say go back to the factored form. So what were my factors that were in the denominator? Okay. On my first fraction, I had an x plus 4 and an x minus 4, correct? On my second fraction, I had x plus 4, and x plus 4. Now, that was kind of overkill, wasn't it? Did I really need to write x plus 4 3 different times? No. But my point is, everything matters, right? Obviously, if they overlap, these two are the same as the one up top. So, what are my restrictions? X cannot equal 4 or negative 4, or plus or minus 4. Okay? You're giving me the signals that class is about to end.
Yeah, 3 minutes.
Okay, so here's what I'm going to say. Tomorrow, first of all, you can go ahead and start B now, or you can start it when you walk into class tomorrow, because I'm asking you to try B on your own. Okay? But we'll start with B tomorrow, and then there's some division examples on that. We'll probably, it looks like I usually do examples A and B, and I don't usually do the word problem. Okay? So if we can get through that in a reasonable time, you could have some work time. Those of you that won't be in here tomorrow because of ASVAB, which there are a handful of you that I just reminded. If you're not in here for ASVAB, that's kind of the plan. And you can even go ahead and take a picture of my notes if you wanted. The video will be up eventually. You can also always get notes from a friend. So we'll finish those. Homework will be due on Monday. Got it? Okay. So multiplying and 2 division tomorrow is my plan.